Welcome, this is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post-Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
Well, good morning, and thank you again for spending your time with us today. My name is John Buselli. I'm going to be moderating this panel discussion on HSMs, although I do want to say we were in preparation for this discussion deciding maybe a late change to discuss the state of hockey in Canada instead, a very important subject, given some of the audience here. No, our objective today is to talk about the state of the HSM market space, and broadly speaking, what are the issues and factors in front of us to ensure that this very vital and important piece of technology stays current and provides utility as it relates to post-quantum safety. So I'm joined here today by four very competent individuals in this subject. I'm going to let them introduce themselves to get this kicked off. We'll start at the end with Niels. Please go ahead.
Sure, and I can tell you, I can out myself, I'm a Maple Leafs fan. But coming back to the topic, Niels Gerhardt, CTO of Utimaco. We provide the root of trust for a lot of digitalization cases in smart cities and, of course, in government. I've been in the industry for 20 plus years, always in security. Yeah, that's about me.
Thank you, Niels. Eric Amador, working for Thales, managing the HSM roadmap. And I've been also in the cybersecurity industry for more than 20 years. And I've been using HSM, and now I'm managing the roadmap of the HSM. Thank you.
Ed Reynolds, I'm a product manager at Entrust for our N-Shield HSM. Spent about 20 years in the cybersecurity industry, started out in SSL, did some work with Symantec, spent 5 years at Thales working with Eric, and so that's me.
Hi, Bruno Couillard. I'm co-founder and CEO of Crypto4A Technologies. We're kind of a late entrant in the world of HSM as a company. However, as a founding team, we've been at this for 30 plus years. And we're very happy to be here today and looking forward to the conversations.
Thank you. In our preparation for this discussion, we thought we might start with something that may be provocative in nature. We'll tie this back into the issue of the day, but to start this conversation, I'd like to ask the panelists here. There's been a great deal of discussion lately about the future or potential demise of HSMs in the market space, given all the factors that have occurred now and with cloud and things of that nature. I'd like each of you to just comment, if you might, on that point and what your feelings are about that going forward. I'll start with you, Bruno. Go ahead.
Certainly what we are thinking of this world, the market that we're in, and the impact of HSMs and their role in our current digital economy, they are absolutely not going to disappear anytime soon, unless we think we want to go back to the 80s. So I think HSMs are here to stay. They are currently going through a change in terms of we need to fix many things of the 90s that we've designed. We need to approach the HSM as a very fundamental element of our digital economy. And I think the HSM has got a long future ahead of it, but there's a lot of work. As we've heard for the last day and a half, we are in for a long amount of our time of work to transition to a post-quantum era, and that implies HSM from the base foundations all the way up. So I think HSMs are definitely here to stay, and they will be useful, and they'll continue to do what they need to do, and they've done for 30 years.
Obviously agree with Bruno. I think that we're going to see some evolution in the way they're offered. Obviously, there's already, kind of cloud-based offerings for HSMs. I think probably each of us has an HSM as a service offering or are developing one. need to get up to speed with the PQC algorithms, but at the end of the day, the creation of digital identities, both for people and for machines, relies on that root of trust. The authentication relies on the ability to take place in secret, and those are some of the fundamental applications for the HSM, and those are not going away. In fact, they're becoming more important and more rigorous.
Thank you. Yeah, I will add to that I mean, the HSM have been used for a lot of classical use cases, but we've seen fundamental transformation in the finance industry, for example, with the growth of crypto assets, digital currency, that will increase even more the use of HSM. We see also the digital identity, as you mentioned. You see this huge initiative in Europe with a digital identity wallet that's going to use also that the foundation of trust will be based on HSM. So not only is it's not obsolete, but it's expanding in more and more use cases, and I think there's definitely a lot of growth.
Yeah, I would agree with that, of course, and I'd say that there is no secure digital economy without HSMs today. I mean, look at all the use cases where they are used. If you use your mobile network, or if you do a payment transaction, if you actually cross a border, all that involves actually HSM technology today. And so HSMs are there to stay, because also in the future, they actually will be a good and a controlled space where you have all your crypto. And then if you actually talk about crypto agility, and we come to some other topics in this talk, I'm just convinced that that is a good place to have it somewhere central that you control and not spread out. And then, of course, hardware also plays a crucial role, because hardware actually can provide you an environment to protect your keys, which is your most valuable asset. So HSMs actually are the key for digitalization, and we see a good growth in this industry.
If I can just sort of tease that apart a little bit, you'd mentioned the alternative of maybe these types of services in the cloud. Would any of you like to comment on either what you've observed or the limitations of that environment, or how current HSM hardware technology collaborates in that kind of architecture? Would anyone like to take on that question? Ed?
Sure. One of the things that is interesting to observe is, for the vast majority of the technology that's been deployed over the years, a lot of that technology has migrated to the cloud, and the cloud has taken on a very significant portion of the market offering. That's almost always true, except when you get to the HSMs. HSMs are a very unique piece of tech that's hard to deploy in the cloud. That the technology that we've built 30 years ago was not ever meant to be deployed elsewhere but in your very highly secured environment. I recall going in early days into customers, and they had multiple doors before you could see the HSM, and there were air gaps and retina scan and handprints, name it. So HSMs were meant to be, from the very moment they were born, as highly precise and highly secure assets. So to turn that into the cloud is a very arduous step. And I think it's going to happen, but we're still working at it. I think the HSMs that we have today and the architectures were never designed to be cloud deployed, and they were not designed to be cloud friendly. So I guess we're still working through that, but the universe is adopting the cloud for so many things. HSM will eventually be deployed in the cloud in the same way everything else is. It's going to take time.
Yeah, and I think it's a matter of ensuring that we have the levels of assurance that we had when they were locked in our data centers, right? You know, you need to be able to guarantee, for lack of a better word, that your security officers are in control of the keys, that you have sovereignty over those keys, and that you're not sharing, you know, that key creation, key generation, and usage environment with somebody else where things could get confused, broken, and otherwise stolen. So, yeah.
But there are also, sorry for jumping ahead here, but there's also different levels, right? I mean, I don't think there's a cloud service provider today that doesn't use HSM technology at the core of the data centers. And of course, then, you know, it's about providing a service to the end customer, the consumer, that actually a tenant on, for instance, an HSM that is then used for other services, for payment applications, for other things that you do securely in the cloud, for protecting your data at rest and things like that. And then there is another layer. So there are independent providers, like probably most of that you see here on the stage, that is actually providing this as a service as well. And that is just to abstract a little bit from the hardware and the complexity of configuring these devices, of having your own crypto team that knows everything about every algorithm, about PKCS11, about all these things that we play around for a long time, and where we actually spin up services to just ease the steps into using HSM technology, protecting your data in the appropriate way, but making it simple, right? So that is actually, I think, where we are going, and I agree with Bruno, there is still work to be done to actually have these services consumed in a way that is as simple as possible as using software today.
Yeah, what I would add to that is certainly most of our customers, they want to have they want to support, they want to protect their data both on-prem and in the cloud. And they need the HSM security, whether it's on-prem or on cloud. And so, yeah, we need to provide solution. HSM has some design that will accommodate this flexibility. Also, what we see, to your question, is HSM is going to grow, is that we see there is obviously very large customers are using HSM, but now it's expanding. If you want to expand and offer the security of an HSM to a larger population, for them it's not very practical to have an HSM. But offering HSM service through cloud services is really opening that those capabilities, those security control to a much wider population. And you're right, so Bruno, on the design itself, and the old design were not very meant to be shared and deployed in the cloud setup. But I think everybody here is working on the next generation of HSM that offer much better segregation and quality of service and all the technical evolution that will make that deployment in the cloud much better.
Well, that's actually a good way to segue maybe to sort of our next general topic. We've learned a lot over the last day and a half on the state of post-quantum cryptography, their performance characteristics, key sizes, and the rest, and various examples where they've been applied and what some lessons have been learned. I think it'd be very valuable for the audience if each of you could just describe sort of how as HSM providers you're working towards being able to incorporate these new standards and technologies. Niels, do you want to start first?
Sure, I can start actually. So we started when I actually started to work for Utimaco, everything was a proof of concept at a proof of concept stage, but that has significantly changed. So customers are using HSMs in their productive environment using PQC algorithms. And our strategy was always to say the algorithms come first, because that's actually where everyone starts to adapt their applications, to work with those algorithms, even though the standards were not there at the time. Now we have standards. Now we actually can work in an implementation that is also interoperable, because standards are out there. And we get more and more requests now. Companies cannot hide behind the fact that there's no standard available, but standards are available now. And HSMs are a good point to start using these algorithms. And of course, you don't necessarily need to use physical hardware. You can also use a simulator. The simulator provides you the same functionality, and it helps you and your team to get educated, to work with PQC algorithms. And then I don't want to actually talk about everything. We have a lot of more things here to share, but one more thing. HSMs provide hardware to do crypto acceleration. So the next step actually inside of such HSM can be the acceleration of these algorithms to provide the right performance level for all installations, including, as we discussed before, the cloud. And that's a good start and a good accelerator for PQC migration to use an HSM.
Yeah, I think we started like Utimaco in 2024. The priority was to help our customer build their test lab, and also to address the most critical use case. So, critical infrastructure have to secure some hardware. So we had a lot of conversation with device manufacturers that are on the clock to protect the firmware of all critical devices that are deployed in the field. So 2024, we had a very limited deployment on PQC for production. But I think 2025, we continue supporting the most critical use case. So firmware signing, I believe, is going to be the big one. And starting to set up PKI. So I think at this stage, we will expose the PKI NIST finalists to do PKI. Some communication as well, VPN, and the product itself will have to evolve as well itself. So we just had a presentation of CBOM. So there is a work that to have a better integration with crypto agility platform. And also, I mean, the harvest now, decrypt later is obviously the top #1 risk. And so it applies to the HSM itself, which means that every time you talk to an HSM, it should be protected with, as well with some MLCAM, for example. So that's going to be 2025 for us.
Yeah, we had the ability to produce a software developer's kit around these PQC algorithms, and what was interesting is the first subscribers, if you will, are those guys, precisely as you said. They were interested in signing firmware, signing code. That led to some differences, though. Now we're seeing, those who we thought they were signing firmware and signing code are actually, injecting identities into their devices, particularly chip manufacturers, guys like that. And they're kind of ahead of us now, right? It felt like 10 minutes after, NIST standardized the 3 algorithms that people were saying, okay, so when's it in firmware, right? We want to be able to run this in production now. So, I think the big challenge for us now is keep up with the people who want to deploy PQ and continue to get things into what we'll call our production environments, into firmware, and again, being able to accelerate those algorithms so that they don't see huge degradation in performance, at least at the HSM.
Yeah, I guess I have a slightly different ability to say that we founded this company on the basis of being quantum safe from the very moment we started. So for the last 8 years, or close to 8 years, everything we've ever done has been quantum safe in nature, from the firmware update, from the attestation, from HSM to HSM transfers. So in August 14th, we received all our certificates for compliance with the PQC algorithm that came out. Back 2 years ago, or a year ago, we had done the LMS as soon as it came out. So we've always been at the very leading edge of that PQC transition. So we have the ability, and it's because we were able to start fresh. So we did not have a legacy customer base. We did not have to worry about maintaining backward compatibility. We were able to step ahead and step forward. So our design, our product, is a very advanced sort of tech. From a pure PQC point of view, we check all the boxes. It's a different place to be. Very pleased to see how the world and the market is actually catching on to the need. And I completely agree with, the world today, the transition that's taking place is where you see manufacturers having to build chips that need to be manufactured in order to be put into systems. These folks are currently running almost with their super stressed. They need to get things going. So we have the ability to help them out today with an existing machine. We're almost done the IUT process of our FIPS 140-3 level 3. So we're very much at the leading edge. And so it's been a position that we've enjoyed since day one. We were kind of a weird voice out there for a while, but I think now we're kind of at the right place at the right time. So this is a different, and I've been in the business of designing HSM, and you get eventually to have a very large installed base, and you have to cater to your customers. We had the luxury of being able to step forward.
Again, following that point, what has been your experiences, and again, to the group, on the performance and operative characteristics? How have you found them in practical deployments at this juncture, based on where you are?
I'd say today, the manufacturers that need to deal with the designing PQC into their products, they're not after performance. They're after the ability to be able to build an infrastructure that will exist for the next 20 plus years, so that they can actually start manufacturing chips and devices. It'll take those folks to have been built in order for systems to start to show up, for the world to eventually advance. And this is where you're going to start to see performance. It's no different than what happened back in the 90s. You start off with, you build the foundations from scratch. First stage, get the functionality, get the assurance, ensure that you have a design that can survive. In that sense, one of the probably the point that has been the most probably frustrating has been the fact that we've had access to this magnificent algorithm like LMS and XMSS. These algorithms, and I've talked to many people, if those fail, if these algorithms are broken, the world at large is in massive trouble. We're all in trouble. So these are your anchor point. If you want to start to build something solid for the future with a very strong feeling of it's going to survive for many years, I think you want to have access to those. The challenge was the one of making them operational. So there were a few challenges there. Hopefully we're going to get those out of the way and be able to make them operational for the manufacturers and so on.
And legacy's a bitch. But it's also a luxury. I think we're going to see, initial implementations. Customers are going to hit, 30 to 50% performance degradation, at the HSM without acceleration. And I think a lot of these trials and customers who are, dipping their toe into the water is figuring out exactly what that means in their environment. In the I'm going to say absence, but almost ready, acceleration of these algorithms. Hopefully, we're going to take that penalty away from them and push it back to the bytes on the wire, as we've learned about here, and then protocols and changes to the number of signatures that you need, and the bytes on the wire is going to become the bottleneck.
Yeah, and I think it's going to be risk-based. So I think customer anyway are going to have to start with their critical infrastructure, their critical assets. And we know there are some limitation in the performance. I know the very first deployment, which was interesting, was Apple, Cloudflare, Google, and they came up with this very clever scheme where they introduced Kyber without impacting the performance, because they were very smart in the way they designed the protocol. So I think probably for the beginning, you will have to come with this smart scheme to accommodate and to avoid impacting the user experience. But yeah, for PKI, for firmware signing, I mean, it's not like they create new firmware every 100 new firmware every second, so it's not really a problem today.
I agree with that, but in the end of the day, performance will matter. So there will be use cases that actually require performance. We see this today. That's why we have acceleration in the HSM, in hardware, be it an ASIC or an XR or some FPGAs that we're using. I mean, that's actually what the HSM is good at, and that will actually come for PQC as well. The initial use cases are, of course, use cases that don't require that performance, but like I said, this is going to come. And then coming and commenting a little bit on legacy, I mean, the whole industry has to, our HSMs have to work in very different setups, and there are known interfaces to the HSM, and there are things that we support and we will continue to support, because in the end of the day, it's also about supporting the transition from traditional to PQC. So we also have to make sure that we have a smooth way towards PQC. We have also invested quite a bit, because you brought it up, Bruno, on the LMS XMSS topic as being considered a very secure algorithm. We have invested also quite a bit of research on our end on how we can actually make this appear more as a stateless algorithm than it is today, a stateful one. So how can we use HSM technology to manage the complexity of these algorithms so that we can use them in a secure way? And we have customers that are actually using these algorithms for signing. And that is actually something where we also, as an industry, all of us, actually see ourselves in helping and to bring forward this research to make sure that going forward we have transitions of whole ecosystems towards PQC secure environments. And I think that is actually one thing that also where legacy helps, because in that case you have interfaces, customers are familiar with the devices and things like that. But of course, we all have to actually go towards the PQC and supporting our customers. The algorithms are there. You can actually use them today on HSMs, and that's a good thing. So you have a defined starting point, and you can use simulators to train your teams, and that is available in the industry to support yourself in your migration efforts.
So we have 5 minutes left, and I do want to make sure we have time for questions. I just wanted to give each of you a chance maybe to describe a critical innovation or a lesson learned that you'd like to impart on the audience as they think about this topic going forward. And so why don't we start in the middle?
Oh yeah, go do that to me. Huh. Critical innovation. Okay, yeah, no, crypto acceleration is, everybody has said how critical it is, right? And the new algorithms are going to tax even our best, latest and greatest hardware. So I think special purpose crypto accelerators within the hardware, something that can be made use of by these new algorithms, or, even to accelerate AES, is going to be super important, because you can't just gang these things up. They're too expensive, right? So each individual box is going to have some form of crypto acceleration to be thoroughly useful with these new algorithms.
Yeah, I think, we are investing. And in fact, Thales is a very special place, because you might have one of a small HSM in your pocket, because we are also manufacturing passport, SIM card, and payment card. So there are, and these devices were super small HSM, right? They also need to be updated and to support those new post-quantum algorithms. So that there is this investment that is done across all the product line to have an efficient implementation that use less memory, less power, and that's going to be able to run this new secure protocol, quantum safe protocol, and it goes up to the HSM where it's going to be super fast and super efficient. So, but we have all the experts to work on this topic, and it's coming.
Yeah, we, again, having been at this for the last 8 years, we've had a chance to build a lot of capabilities. Our foundation is an FPGA product, which allows us to really balance the performance that we achieve. For a certain while, we'll have to probably be able to offer equal performance from a classic crypto to that of a PQC crypto. I mean, you could be super powerful in a classic, but if your PQC is dismal, you may end up having 15 boxes just to do the PQC. So we felt that being able to balance this using the FPGA fabric and allocating the capability was a decent thing to do. And then over time, we have the ability to reassign that FPGA fabric. And by that point, we expect the world is going to have come out with actual ASIC acceleration for PQC. Now, this is a few years away. So we felt that for the transition that we're about to embark on, having a technology that allows you to balance things as a system designers would like to was really critical. Another piece of really important thing we did, which we feel is going to help, is the very strong cryptographic separation between who owns the HSM and controls the HSM from who owns the keys and controls the keys. So there's a cryptographic separation here. And the beauty of that is it allows someone to manage and distribute and operate the HSM machinery without ever being able to have their nose at your keys. So you may not need to own the HSM in the future in order to control and manage your keys. Today's, you typically have an HSM, you build a key in the HSM, and that HSM owns your keys. So you better own the HSM. We're trying to separate that so that the world of tomorrow has a more flexible capability, especially in cloud deployments and so on. So I'd say those are two main ones. Niels?
Yeah, just very quickly. I mean, you have the PQC algorithms supported today. You will see acceleration. You will see certifications for this HSM technology. But I want to change the view a little bit. I mean, the cool thing about HSMs is we work with all the industries out there. So the HSMs are used to protect the control plane of satellites. They're used to do firmware signing, and the chip may be ending up in your electrical car. Or you have some other critical infrastructure that these HSMs are working with. We also need to make sure as an industry they work with new technologies like confidential computing. So some say, confidential computing could be the next HSM, and but in combination, that could actually be a good solution going forward. So for me, the big innovation we need to bring to the market also as an industry is we have to work with all these new and cool technologies out there and find a good way to secure them using the HSMs, and using the HSMs in the right way for that. That's, I think, where a lot of the innovation will come from.
Thank you. Great points. At this point, we'd like to open it up to any questions, whether online or in person. Please, in the room.
Hello, I've got a question which is basically based on a ongoing IETF discussion. I have a gigabyte image that I want to sign. How do you do that in a performant fashion?
Who'd like to answer?
Using MLDSA.
We have the ability to do that today. As an HSM vendor, we don't view ourselves as being part of the debate. Ultimately, the users should be able to choose whatever they need to choose.
So we download the entire gigabyte image to you?
If that's the way you feel like it, yes, but it's going to cost you some time to go back and forth.
Yeah.
So we support that, but we also support the other model, which says, go do your hash, give us the hash, we'll sign it. So those two things is what we offer. We tend not to pick a winner in any debates. We're an HSM vendor. We should offer as much crypto agility and flexibility as we can.
Okay, fair enough. Just that you ridiculed the idea of 100 firmware signings per second. I believe that we on burst times can actually achieve that.
Yeah, and we have the async capability from an LMS.
Okay.
Yes, essentially my question is for the FIPS validation for your HSM suite. Is it going to come as a new firmware from the vendor, or is it going to come as a new appliance we need to buy?
Well, in our case, it's going to be a field upgrade. So just if you have support and maintenance, you download the firmware upgrade, and you will have the, MLKM, MLDSA, LMS in production. So, you see that in the presentation, it's going to take 1 year to get the certificate, but you're going to be able to see the ACVP test result quickly. And so that's the way it's going to work.
I think our approach is going to be identical to that. We'll have firmware upgrades that support the new algorithms. Well, obviously, because we've made a change, we'll have to go back through the review process, and that certificate will come when it comes out of the black box. So
no change here. Only one small comment. We also have the ability to use SDK functionality to add algorithms at a certain point, because we still believe some algorithms will come, like Falcon or some others, to be implemented and supported by HSMs, just because some industries, some use cases are requiring different algorithms than just the standards we have today. But just side comment. But otherwise, same as the other.
Quickly, we'll basically provide a firmware update where our firmware is probably a few months away from being in the MIP mode of FIPS. So we're going to be in that year-long wait. And that's ready to be deployed anytime you're ready to accept it.
Thank you.
Thank you. Well, we're at the end of time. What I'd like to suggest to the online audience is I'll go through the questions and ask my colleagues perhaps to comment on them online. I want to thank you. We covered a lot of ground in a short amount of time, and I do appreciate that very, very much. So thank you. And next, I can imagine it would be an interesting effort to reconvene the group again next year and see where we are, if that's at all of interest. And I guess we'll just have to wait till later to find out what the state of hockey in Canada really is at this point in time. All right, well, listen, thank you very much, gentlemen. Appreciate it.
Thank you.